We're proud to announce CISO Stories, a new podcast series in partnership with Cybersecurity Collaborative and Cyber Reason. CISO Stories features the candid perspectives and experiences of frontline senior security executives and dives deep into timely security topics. CISO Stories is hosted by Todd Fitzgerald, VP of Cybersecurity Strategy at Cybersecurity Collaborative, and Sam Curry, Chief Product and Security Officer at Cyber Reason. Listen weekly as they speak with extraordinary CISOs by visiting securityweekly.com/CSP. Welcome back, everyone, to Paul's Security Weekly. Do you have a specific guest or topic that you want us to cover on one of the upcoming shows? Submit your suggestions for guests. We'll take out that blanket. We'll cover them right up. You can visit securityweekly.com/guests. Complete that form, and we review suggestions on a monthly, weekly, every now and again, sometimes basis. In this segment, I would like to welcome Antranig Vartanian, the CEO of Elluria Security. Antranig started his career 10 years ago as a systems administrator and part-time OS developer. After a couple of years in operations, he started working the only security engineer at Armenia's National Computer Emergency Response Team. Tonight, he joins us to discuss how rapid change in Unix-like systems have affected their security state. Antranig, welcome to the show.
Hi, Paul. How are you?
I'm doing great, my friend. Antranig and I go way back. Well, at least as far back as I started advising his company, Elluria Security.
Yes, that's correct.
I should probably disclose that.
Well, greetings from the other part of the world.
Yes. Nice to have you on the show tonight. Antranig, how did you get your start in information security?
Oh, that goes way back. So I was born in Armenia, but when we had the war in the 90s here, we went to Syria. Then when the war happened in Syria, we came back to Armenia. But while I was in Syria...
people talk about having a rough childhood. Like, based on what you just said, like, those people need to shut up.
When you are in Syria and there's a lot of sanctions happening, you follow the mentality of less is more, right? Yeah. And when we had this problem where we didn't have the latest and greatest computer equipment or the best internet connection, and most importantly, many things were locked down either by the government, things like Wikipedia, or by companies. For example, Apple's services would not work, even simple things like the App Store. So that's why when you're like a 12-year-old kid, you start learning how to bypass these problems, right? How can I use a proxy server to use some kind of Wikipedia pages, and how to jailbreak an iPhone and talk about it with the community on IRC so I could install apps on my iPhone. So you kind of had to know these things in order to use technology in these kind of countries. But I think my main kicker was when they started adapting Wi-Fi in the country. And there was no regulation, no security laws or anything. And reading one thing led to another, and I discovered something called aircrack. And that was my first introduction to Unix and hacking as a concept and as a way to survive in a country like that. So I think that was my actual first time interaction with InfoSec itself.
And where did you pick up your knowledge of BSD? Because your platform, I believe still this day, is built on BSD, correct?
Yes, that's correct. Our platform is built on BSD. I think so. My first interaction with BSD was due to curiosity. So when I came to Armenia, I was not planning to have a career in computers at all. I was planning on to be a linguist, but there was an open source Linux distribution in Armenia. Basically, the whole concept was it's supposed to be in Armenian. Everything is supposed to be translated because not everyone knows English, etc., etc. And I found the project. I found a couple of bugs, and I sent them a patch. And the next day, I see that their CEO is telling me, "Would you care to have a job here?" So their system was running Gentoo. It was built on top of Gentoo, and reading Gentoo's, yep,
it's painful.
For me, it was fascinating, like to be able to tune the computer. But now that I look back, it's like hours and even sometimes days spent on just compiling stuff.
Yeah. So it's fascinating for like a few months, and then you're like, oh, yes. Good lord. Yeah.
Yep. Mm-hmm. First time I ever went to install Gentoo, I looked at the install instructions, and they were like 13 pages, and I'm like, nope. Nope. With Red Hat or Ubuntu, I could go click, 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 and would start installing. I'm like, yep. Yep.
Oh, come on! It's just click, click, click. Wait 7 hours. What's the big deal? Okay, come on.
And then you have, and then you have 12 more pages of things to do.
Yeah, but that's a great learning experience.
Sure.
And back on your story,
Correct.
right? Of learning. That's how you learn.
Yep. Well, Gento's portage, their own compiling and package manager, was built on the concept of FreeBSD ports. So that was my first experience with FreeBSD.
Right.
And I had that moment of aha when, like in FreeBSD, I could use both the ports tree to compile whatever I want.
Right. Except in FreeBSD, it works a higher percentage of the time. Not all the time, but a much higher percentage than Gentoo, at least in my experience.
Yes.
Yeah.
Yes, that's correct. But they also had the package stuff, which is basically a PKG to install whatever you want. So I was like, oh, this is perfect. This is like a very good fit of balance and everything. So I got started with playing with the BSDs. I even had a couple of jobs doing BSD administration, and it was pretty much very fun.
I miss FreeBSD. I haven't worked with it in so long. I did OpenBSD for a little while too. My question for you, and I was thinking about this when I saw you were coming on, Antranig, was all of the pretty major now bugs in the Linux kernel.
Yes.
Those the BSD kernel though draws its lineage from code that was produced way before even the Linux kernel was, right? Do you like what's your general sense about, like, have we just not found all the bugs in BSD, or is there not as many people looking for them? Are they looking at Linux because it is so widely used now? Like, do we have this Microsoft and Apple problem? Like, oh, I use BSD, I can't get viruses, right? And I use Linux, and now I can. Like, the tables have kind of turned. Like, how do you see that comparison?
So I was listening to your talk with Daniel moments ago when he said, like, the best way to defense is to shut down, and the main reason why I wanted to talk about this is actually when Dirty Pipe came out, 2 days ago was it?
Yeah, I think, very recently.
A friend of mine said I have to do something because like basically now everything is exposed and I have to shut down everything for at least a moment at least. And I said, why everything? And then I realized that we don't have Unix diversity anymore, right? Some companies, they think about these problems very early, and they deploy both on, let's say, Linux and FreeBSD. They deploy on multiple types of Unixes. So in case a huge vulnerability comes out on one of them, you can still mitigate by shutting down only your Linux boxes, but keeping your FreeBSD boxes up and running. But from the historical point of view, I don't think that FreeBSD doesn't have like less bugs. Of course, the number of researchers who look at it are much less. But if you look at the security adversary of FreeBSD's, their RSS link, there is something happening at least like once every 2 months. And most of the times I realize that they publish multiple things at once and one patch level to mitigate, let's say, 4 or 5 types of security vulnerabilities. So there are people who are looking, but what would happen if more people would look? I'm not sure. But the beauty of this in the BSD systems is because unlike Linux, it's a whole operating system. It's not just the kernel. It's the kernel plus the whole userland tools. The FreeBSD has the advantage of doing security testing on the operating system. I think it would gain a lot if we were able to improve the FreeBSD project by doing security testing on the whole operating system with every release, every Git push, and we would see if something went wrong, etc., etc. So that might be one of the advantages of FreeBSD if a couple of things were done better. So those are my only thoughts on that. But I wish if more people looked at other Unixes as well. I mean, other than the BSDs as well, we have the Solarises, the Lumos distributions, and God knows what.
Does that apply to the containers and stacks that are being built around that? Because you have kind of the same concept, and there's a lot of work going into some of those as well.
That's right. I mean, people these days talk about containers like it's a new thing, but then especially when you've been running Gentoo for a while, you know that chroot is a thing, and then chroot got evolved very, very well in FreeBSD jails, which is very mature, I wouldn't say it very secure, not because it has vulnerabilities, but maybe, back to the Paul's point, what if no one actually has looked at it that deep like they do on Linux, right? But you have the FreeBSD jails, and then you have the Solaris zones, which came after FreeBSD jails, and then you have things on Linux. But the container system on FreeBSD, it sounds more secure in the sense that the code base is a lot smaller. I realize that in Linux, when we talk about containers, it's basically an integration of multiple things happening at once, from C groups to namespaces, etc. But on FreeBSD, the concept of a jail is just a jail. It's basically the core system itself is 3,000 to 4,000 line of code to make a jail exist. So it's simpler, right. It's smaller. So I think that's also has some kind of an advantage of you, if you want to use containers, or basically system isolation. You're not limited with the Linux stuff like Dockers and everything else, but you can also have the Solaris zones and the FreeBSD jails as well.
That's interesting. Now I want to read articles about what the differences are between Docker containers and FreeBSD jails and Solaris zones. I won't make you go into detail here, Antranig, yep. But I think it's a good exercise. Yeah, having been focused on Docker containers, right? Myself.
So is there a lot of advantage, like someone that is not typically looking at or running something like FreeBSD or even Linux at this point? Like, what are some of the advantages, and kind of where is the state of security for the Unix world for those of us that kind of maintain our dwelling with inside of the Windows world or Active Directory world? Like, what kind of stuff is out there? What kind of security is going on, and what kind of advantages are there?
So I've realized lately that ransomware is the thing. Everyone is talking about ransomware, and even here in Armenia, I mean, as a security company, we get calls every week about some cheese factory that got ransomware, and they want some assistance. And then you ask them.
But if you haven't had Armenian string cheese, you haven't really lived yet. Oh, is it peppercorns? What is it? There's like a little.
No. It's
not peppercorns. Is it? It's. Oh, it's delicious.
Damn it, Nigella seeds.
Oh, so good.
Yes.
Anyway, sorry.
We do have a very famous cuisine. Yeah, that's correct.
My wife's family is Armenian, and so I get fed Monty, and my mother-in-law had to take a pilaf test before my father-in-law would marry her.
Wow. Okay, that's wait, screw all of the security stuff.
Yeah,
so how was the pilaf?
I just got to make some rice, but just making rice pilaf is different. No,
you have to fry the.
You got to brown those. You can't burn them. It's very yes.
Yeah, you have to fry the noodles in butter, and like
yes.
Like her pilaf is fantastic, by the way.
See, now I feel like we need Chris on. Chris is the one that's always eating, not you.
Chris is the foodie.
Yes, he's the food guy.
Yeah.
Oh
my!
So
what were we saying? A cheese factory got ransomware in Armenia. That's the guy that's on this whole path. And that was just a hypothetical. We're not saying that really happened either.
Yeah.
So they got ransomware, and a typical question, you say, well, maybe I can help you with the recovery part at least. And you say, where's the backup? And their answer is, it was on the server itself. A very typical scenario. And then you teach them how to use a backup server. And then a couple of months pass, and they call you again, and they say, well, we got ransomware, but now the backup server got ransomware because they forgot to update something.
Oh, wait, was this also the cognac factory? Is that why I haven't got my bottle of Armenian cognac yet? Because they got ransomware?
If you haven't got your Armenian cognac, then you have to ask Tyler. He's got your Armenian.
Is that because Tyler drank it all on me?
He drank it on the plane ride home. He didn't even make it to the States.
I made it back to the States with it.
Yep. Hasn't made its way here. Just saying.
Never will.
Throw it out there.
Never will.
Little inside baseball.
Sending gift to
what are we talking about? We're talking about ransomware.
Server got ransomware because it didn't patch something.
Yeah.
In their backups got ransomware.
Then what I realized is if they used so most of these attacks happen on the OS layer, right? If you look in their code, they open the file, they encrypt it, they close it. Very little of time that they use any kind of file system specific actions. So what I thought is this is a perfect scenario to use a complex file system like ZFS or BetterFS. And one of the benefits in the Unix world is now ZFS has got first-class citizenship in almost every operating system. The Linuxes, the FreeBSDs, and the Illumos, where it was born historically. So I think from a security perspective, it would be very good advice to tell people that while some people are focusing on the recovery and the prevention of ransomware attacks, on the other hand, you also have the mitigation mechanism, in the sense that if your data got corrupted, you can use something like ZFS and Bitrefs just to revert back to the last thing that you had. And then one of the main reasons why people, especially in low budget countries, like someplace like Armenia, why they don't have a backup server, because it's expensive. Like it might be $80 in the States to buy the disk, but it's also $80 in Armenia to buy the disk. But the $80 has different values here and there. So then I realized that if we had a file system who has a very good way to back up the data, something like Time Machine on Mac OS for a typical user, where it can do copy on writes, etc. ZFS is a perfect fit for that. And many people who love FreeBSD, they do use ZFS. Many people who love ZFS, they do use ZFS. But we have to also bring awareness to the typical IT department that you need something even out of the box like FreeNAS to back up all of your information. And we've had this problem a lot. And I think to answer Tyler's
that
question,
backup needs to be one way, but you don't want to overwrite your backups with the encrypted data as well, right? So there needs to be some kind of snapshotting that is protected.
It is snapshotting.
But you have to protect that, right? So that it can't get overwritten with if it's constantly backing up, at some point you're going to overwrite that with the encrypted data.
That's one of the things I do like about ZFS is I have to ask, is it ZFS or ZFS? I hear both.
I'd go with ZFS.
Depending on where you are on the planet, whether they call it a Z or a Z, right?
Mm-hmm.
Oh, okay, interesting.
So UK would be Z.
Go with Z.
Yeah,
it
go
sounds
Z.
better.
Yeah.
Z.
So with ZFS, because you can back up and do snapshotting at the same time. Basically, you're sending your snapshots back and forth. And if your latest snapshot was encrypted, but the one before that was unencrypted, you can also revert back to that. And that's one of the key points that we've actually had a success story, maybe I could say, for a friend that I was helping out in his company, and we've set up the small box, and I taught them, basically use the SMB folder for all of your documents, and the SMB over, the network, and what happened in the end is they did get encrypted via ransomware, maybe a couple of months later, but he called me immediately, and I told him, okay, shut down everything, because you don't know how they got in. All you care about right now is your data. Go to your FreeNAS machine and type the following command, which is, ZFS restore, blah, and you're done. Now you've got all of your data back. Now let's try focusing on how to find the problem. How did they get in? Was it some kind of malware in the network, or did someone click on something? That's a different problem that we need to solve. Right. But to answer Tyler's question specifically, is this innovations happening in the Unix world that can assist the world outside of Unix? ZFS is a huge advantage. And I realized lately that ZFS is also available on Windows. It's not feature complete, but the basics of it are. So maybe even people who are running Windows servers can use ZFS.
Lee?
So I have a question for you. I mean, you're using technology to solve human problems as well as technical problems. And it sounds like you've answered these questions multiple times. Have you considered putting together a blog or other, hey, these are the 10 things you really got to do before you call me?
Well, I do have a blog. The Armenian one is very active, is obviously, but the English one, I basically complain in the English one instead of writing advice on the English one. I know I complained about Unix portability and things like that. But maybe that's a good idea. And if I had to write about 10 things, I think for the typical IT department, backup restore is the first thing. But at the same time, I think doing proper backup restore is the other question. Because if you have it's the Schrodinger's restore. You never know is restorable until you try to. So that might be one of the first key points, right? But on the second hand, I'm trying to think that with most of the problems that I'm seeing on this part of the world, also production servers being hacked that are running Unix. I don't know how IT departments are there, but does everyone still disable SE Linux?
Yeah.
Okay.
Well, I mean, I think there's a lot of you lost the light.
It's the automated lighting. I wasn't moving enough.
I got you. I think there's a lot of subsystems and security controls in Linux that some of which, depending on your Linux distribution, might be there or configured. They're there and configured in a specific way. Some are turned on by default or not. Setcomp and Linux capabilities are ones that come to mind from working with containers and things of that nature. So there are controls like that, but I feel like in Linux they're tuned. If you run Ubuntu, they're tuned in a certain way to allow things to operate, not necessarily like lock everything down and I have to go turn it on to make it work because then people would move from Ubuntu to some other distribution. And I think is my theory.
I think maybe that was a little bit of a joke that got lost, and I don't think that in my experience many people actually disable SE Linux. I think default tunes are workable enough that no one needs to turn it off anymore.
Muck with it, yeah.
So and the default tunes for the most part might as well be turned off. So it's not doing a whole hell of a lot.
So do you find a willingness for folks to learn how to raise the security bar, or are they just overwhelmed and just can't get much past clicking install or rebooting?
So what I've realized is with things that are created to make systems more secure, and this is a typical InfoSec problem, obviously. Do you want better security or easy of use? But a couple of months ago, I started using my MacBook again, and this time I said, okay, I'm going to use it the Apple way, so I don't complain anymore on my blog. And I started also reading logs on how my MacBook actually does work. Then I realized that Apple's macOS uses FreeBSD's Audit D and the mandatory access control subsystem internally whenever you click, allow permission for this and that. And I've never had a usage problem because all I see is just a small window that says yes or no, allow or deny. So it got me thinking that maybe outside of the desktop world, we're doing things wrong. Why can't we do the same thing there? Like, okay, Apache is trying to do something to open a directory. Maybe you got hacked, there's a vulnerability, you have an RC in your application, or maybe you just have bad configuration. It's up for you to know, but we need a way to just give a simple way for users to understand that they have a problem, which is basically my philosophy, at our company, which is whatever you do, prevention is going to be very hard. Just do deception and detection instead. It could be at the end of the day a lot easier and cheaper for you than actually fine-tuning all of those systems. But I wish we did live in a world where you could just say, yes, allow Apache to access this file or not. Because if Apple could do it, but of course they do have a lot of money, but they did implement these things a long time ago. I went up to their source code, and I think it was like 10.6 or something, which is like 10, 12 years ago at this point. So it got me thinking that we don't have the simple mechanism to tell the user what's happening. While I look at my friends' companies, they see something is not working. The log says it's SE Linux blocking the access of something. Next thing they do is disable SE Linux or whatever security feature that they have. I think AppGuard,
AppArmor,
right, on Ubuntu these days.
I know because I had to turn that off. So things can actually be vulnerable, right? You get a default AppArmor profile that Docker containers implement, and so if you want to make things less secure, right, you got to go start mucking with that stuff. It's interesting though, Antranig, if we could. Like anytime you define these very stringent policies, there's always exceptions, and then the default tends to be more open than it should be. And even if you take the time to tune them yourself, then a situation is going to arise where you have to tune them again. So basically, we're incurring much more maintenance in I guess my question is, the juice worth the squeeze, right? Do we put these strict policies in place knowing it's going to be a constant cycle of tuning them? Is that more secure, less secure? You could almost debate it.
I think OpenBSD, which is very famous for being, for security and for the paranoid people, I installed their latest version a couple of days ago to see what's happening there. And I've always used Firefox on it, but I ended up needing Chromium. So I download Chromium, I install Chromium, I use Chromium. Then I realized something. They implemented
Chromium crashes. It definitely
doesn't. But I will let you know when it crashed.
Yeah, I tried on Linux and it crashes a lot.
So I look at Chromium and I need to upload a file or something. Then I realize that Chromium is only able to see two directories. The downloads directory to download something, and the .config Chromium directory for its own configuration.
Yep.
And basically what OpenBSD people said is, if you're using Chromium, these are the only two directories, don't try to do anything else. I ended up, using the command line in Finder or whatever it is to, select the file in TMP. And at that point, Chromium crashed, which got me into searching of what's happening. But then I talked with the community and they said, well, this is good. Like, we know we have this security mechanism because we patch Chromium, we add the system call that we need, so it will never be able to see anywhere else. But that also means that it will not be able to see anywhere else, and we have to bind by the rules that OpenBSD is using to look into to use Chromium. And I asked a couple of friends here and there. You have the two types of the specter always. One of them are saying, no, I need to have full control. I have to decide with what to do. And the other one says, well, if it's going to make me more secure, I'll just end up doing whatever the vendor is telling me, whether being FreeBSD, OpenBSD, or any kind of Linux distribution. So my personal point of view is obviously the more secure one. I would prefer to have a little bit of more pain, but know that this system call is going to crash a vulnerable application that is doing something it's not supposed to do, instead of looking, the more liberal way of I can do whatever I want, but that also means that maybe one day an attacker can do whatever they want, right? So it's a typical division, but it's a good thing to see these kind of innovations in system calls and mitigation mechanisms in Unix systems outside of Linux as well. And it's a good thing that we can learn from each other. SecComp is very similar, but it's not as easy as OpenBSD's latest sim call. I think it's called Pledge. No, it wasn't Pledge, it was the other one.
Yeah, no, the problem is these technologies combine on, so you got your SE Linux on top of SecComp, on top of AppArmor. It's like all these layers. Yeah. It makes things even more confusing.
And they just don't work when you layer them that heavy.
Well, then you end up just scaling back all the policies to make it work. And then that defeats the purpose, right?
Right. Well, that's the point. I mean, look, you've got a security versus usability conundrum in everything we do. When you add on AppArmor and SE Linux and don't let anything work Linux or whatever the hell it is, it's going to break so badly that somebody's going to go, just turn it all off. I mean, let's be honest. Any is a legitimate firewall rule. Doesn't do much firewalling, but it is a legitimate firewall rule.
Yep, and everything works.
Amazing, isn't it? Including the bad guy stuff. It works just perfectly. Yeah.
Is the OpenBSD and the FreeBSD and the use cases for those, are those often well used and a good situation for things like firewalls or appliances that may not often get patched or may have kind of a different, less hardened OS or software layer that could be abstracted better with something like BSD?
So I think yes. I don't remember which year it was. I think it was 2018 when there was a vulnerability of not DOSing. It was some critical vulnerability in Nginx, which allowed you to read any file that you wanted, as long as it was in the directory of the server config. And I tried that vulnerability with the vulnerable Nginx version and the exploit and whatever I found, and it worked perfectly on Linux. And as a matter of fact, it also worked perfectly on FreeBSD. But then I tried the same thing on OpenBSD and something called Hardened Bsd. Many people have not heard of Hardened Bsd. It's basically FreeBSD with a lot of hardening features on the compiler and the OS level, like very strict address layout randomization, etc., etc. And when I did run that exploit there, it didn't work. Of course, it got DOSed, like it crashed. The Nginx process basically just died. Then it restarted itself. But I think those are very legitimate uses if you want to have a more secure but also more painful environment for any kind of appliances. For me, from the security perspective, what I've always liked is to use the PF firewall. It's very famous. You have pfSense, OpenSense. Many people deploy the firewall on OpenBSD itself. And the reason why I always got, close to it is because it's human. Like, you don't type IP tables -J-O- whatever it is, and then maybe you miss something. Instead, you say allow from this to that. And teaching a couple of my friends how to use this firewall, for them it got very, very interesting. Now they spend at least an hour when they're configuring the firewall, but they will make sure that they are configuring it very, very properly. I think Linux has an abstraction for that, right, Paul? I think it's like the UFW, user firewall, or something?
Yes.
Ubuntu firewall?
Yes. And I think the major difference is the chaining and forwarding rules. That's what makes IP tables, I think it's really powerful to have that, but it can also be really error prone and difficult to troubleshoot or modify, especially was in a situation where there was IP tables and multiple chains were called different things and forwarding to each other, and to like unravel all of that hurt my brain. And I eventually figured it out, but you're right, there's better, like more straight, it seems to me PF and UFW, right, are more straightforward, here are my rule kind of things. But great power in the IP table. So it's somewhat of a trade-off in the problem you're trying to solve. I think for a lot of my firewalls are pfSense because it's no nonsense. It's firewall, and they've abstracted a lot of that into the GUI. You still get a command line if you want, right? But it works really well as a firewall. So I guess I do run BSD on my firewalls.
Of course, yes. Well, I mean, it's pretty famous operating system. It doesn't get much media attention, but on the other hand, like Netflix's CDNs, they all run FreeBSD. I think they're doing now like 400 gigabits per second streaming using those CDN servers that they run.
And so my always kind of thinking on that, Antranig, was that in the BSD kernels and operating systems, the TCP/IP stack is just wildly performant. Like, it's just it's a well-oiled machine. With Linux, you can run into some funky stuff. You might have to do some tuning and stuff like that. But a lot of those higher-end things you're talking about, right, that have to process a lot of traffic, end up using BSD under the hood for that reason. It sounds like that's still the case.
It's still the case, and we've had scenarios when we did a couple of benchmarking for our. Well, I was a CTO at a SaaS company for the domain name selling stuff, and it happened that at some points of the month, many traffic was coming from China because apparently they buy domains with like only numbers. It's a thing there. Because they don't use letters, instead they use the hieroglyphs, instead they use the numbers to represent the hieroglyphs. And like one day of each month, there's a huge traffic coming in, and the servers were just running, dying basically. What I ended up doing is just migrate a couple of things to FreeBSD, tuning a couple of CCTLs, and next thing you know, we're paying the same VM price on the cloud, but now the CPU is on 50% idle, and everything is being served very fine, and they do have a very good TCP/IP stack. Of course, it originated there. I think that's one of the main reasons. They know the whole historical thing. I mean, TCP/IP was created on the BSD OS back from the university days, and then it got more widestream. I've never seen the old days because apparently there's something called like Apple Talk and multiple other protocols. I never had the luck to see them.
Apple Talk was a thing. So was Net Talk. What was in Novell? Novell. There was like bridges to Novell.
I am not going back to my Novell days. And yes, I am a CNA or CNE. I forget what I was back then.
Yeah. Oh, come on. You haven't lived till you did the 3Com stack with 17,003 drivers to make it all work.
Oh, yeah.
Oh, wait. I've got two words that'll make you cringe.
Token
Banyan
Ring.
Vines.
Oh yeah, that was another one.
Oof. I think Josh just won the internet again.
Yeah, I was gonna say DECnet, but I think
Yeah.
FTDI.
Oh yeah.
Fitty.
Well, how about SNA over IP?
I remember seeing references to that. I don't know if I ever did that. I wanted to come back and talk about containers, because I do a lot of container stuff, and it's mostly Linux running Docker with Docker Linux containers. How does that translate to BSD, and what's your recommendation for how to use that if you're going to mix? And are there like security, like should I use BSD as my host operating system, and can I have Linux containers? Do I use jails instead of containers? Like, I want to hear your thoughts on that.
So I always bring this very simple analogy of containers on Linux, especially Docker, were built at the DevOps era, where FreeBSD jails was built and created at the sysadmin era. Because the jails themselves, they just allow you to isolate the system into multiple parts, okay? The main purpose why it was created...
So Antranig, jails are more for process isolation and control what a process can do on your BSD system.
Yes. The actual purpose...
Containers are more about the application, making an application work. I think I captured that. That's the way I understand it. Okay.
But, so we do this hack if we want to run a container in jail, or a jail as a container, is that the process that it runs is the init system.
Yeah, okay.
Then everything after the init
BSD
system is
so much
jail.
you can run BSD inside BSD in a jail.
Yes.
Yeah.
Yes. And it works fine. Many people, that's how they isolate complete operating systems in the jail system. But FreeBSD also has this thing, which is the Linux KPI, right? The kernel programming interface is implemented inside FreeBSD as a translation layer. So we know this Linux system call translate to that FreeBSD system call. And this has allowed people, including me actually, to run Linux processes inside FreeBSD, whether be it in a jail or not. So I do have a couple of applications in my home server where I run some kind of, let's say, software, mostly proprietary stuff that are not available to be ran on FreeBSD, but they do give the proprietary binary for Linux, and I just run them very fine, which is a good way for me to watch Netflix, because I need Wave something for DRM, which is available in Chrome on Linux, but there's no Chrome for FreeBSD. So I just run Chrome that is built for Linux on FreeBSD. But my biggest concern with and
that can be
that's
wonky. We've all seen systems like that where you're processing system calls in that way can get wonky.
Yes, and that's my biggest concern is now FreeBSD is also running drivers that way, because we don't have enough manpower to, implement all the graphics drivers. Yeah, which is good. The mainstreamness of Linux is bringing us a lot of value to run graphics drivers, etc. But then, it's built for that, not built for this. Sometimes the code can get very ugly. But again, the community is doing the best that they can. But my biggest problem with all of this Docker thing, which again, I love Docker in the sense, I think there was a quote from Brian Cantrell where he said, Docker will do to apt what apt did to tar, right? In the old days, you download a tar, then you find the dependencies, then you bring the dependencies, then you compile that, then you have apt. Now, apt still uses tar underneath, but it does everything for you. And now you have Docker, which is basically replacing apt. But the problem here started with, well, two things. We are not writing portable programs. So when you tell someone, when someone tells me my application is portable, I'm like, what do you mean? And he says, or they say that, well, it runs both on Ubuntu and CentOS. I'm like, that's not portable. It's the same operating system. It's just Linux.
That is, well, now you get into the major difference, I think, between something like a FreeBSD and Linux distributions, is that every Linux distribution is different, and packaging. This is something Linus Torvalds said, that the biggest thing that is killing application development, and I'll extend that, I don't think he said this, but I'll say killing Linux on the desktop, is if you make an application, you can't just make it for like one Linux distribution. You got to package it differently, and it's all different for all the different distributions, right? Whereas for FreeBSD, it's a much I can make my package work for FreeBSD, and it works, and it's great, right? But now it's Ubuntu, it's Gen 2, it's all these new Linux distributions. They come out all the time. Some of them are really good, and are doing great things. But that interoperability, I think, gets lost.
My family never used Windows because I was able to just give them, I think, Mate Linux, was it?
Yep. Yeah, Mate.
And they're like, this is all fine. Thank you very much. I can use everything here. I have my browser, my Skype, whatever it is. And they never needed a Windows system, which yes, some desktops on Linux are good. But there's also a project named Evpf. Ever heard of that? It's made by Simon. His username is ProBonoD. He made this amazing facility called Evpf, which is basically you can turn any Linux application, and he also lately added also FreeBSD support, any application at this point, into like a static folder, like .app on macOS. You can just bundle anything that you want, put it on any Unix and Linux that you want, and just run it.
Yeah. I think I did read an article about that. But it's again another packaging system, right? Do you use Snap? Do you use App? Do you Evpf?
Flatpak or something, yeah.
Yeah, and I think the open source is a beautiful thing, right? But the kind of double-edged sword is that interoperability, which also it hurts security too. Do I secure this application? How? Because how is it running? How is it packaged? I think that's some of the promise of Docker is that I can put it inside of a container and secure it inside that container. The problem with Docker is that you can screw it up by how you run that container. And you can throw all that security out, -- privileged, and now you just throw all security right out the window.
That's why another problem with Docker is we've spent 20-something years making Unix-like systems better. So you don't run Nginx as root, you don't run a binary as root, you run them appropriately. But then Docker came, and now you're running everything as root, or maybe you should not run everything as root. But then some person who's having a problem because it can't listen on port 81, now your Node.js application is running as root again. So. It's wonderful where the DevOps culture moved Unix-like systems to, but I think we should not forget about the history of why we did some things. We have to always remember, we did this because of that security purpose, that usability purpose, that portability purpose. And trying to bring back portability, there's a nice effort going right now on making FreeBSD jails OSI compliant. So you can run it, back and forth, because with that kind of accessibility, it will also teach us to test things better and debug things better and bring the tooling of other systems into your own application. But I hope that we will get to a day where we say, okay, this is the new POSIX, right? That's the old POSIX of system calls. This is the new POSIX of the modern DevOps world. And now we can all run regardless of our operating system, everything with this set of features, and everyone will be happy. And hopefully everyone will be secure as well. So I think history has a good class here. I'm very nostalgic because my first Unix system that I saw but never knew what it was a Sun workstation from 90s in our school that was just, being seen as a garbage. And then to see how the same commands on my aircrack image running on my laptop and running the same commands on school is this is amazing. But then people wanted to change things. Instead of making ifconfig better, now we're making a new tool called IP. Instead of making security better, now we're rethinking security all over again on Unix-like systems, specifically on Linux. But
Yeah, I agree. I think some better standardization is in order, right? And you can kind of see some of the benefits. So I had some containers, they were running Debian Buster, which is older. And I'm like, I need to upgrade them. So I'm like, all right, just swap out that from line in my containers to Ubuntu 20.04. What could go wrong? And I was totally expecting shit to blow up and go sideways. I was like, even like our CTO was like, you're really brave. I'm like, wait, let me finish. Like, I did that totally expecting like shit to go sideways, and like magically everything just kind of worked. Right? And I was like, wow, if we can get to this place, whether you're BSD or Linux, maybe even independent of that, and be able to update things and push forward without having to go back and like replumb everything, we've made some real progress. And I think that's what you're kind of hinting at, Antranig, right? Is being able to have the interoperability to run applications and processes and not so much care about what's underneath all the libraries that are linked to it. Like, it just runs, continually upgrading and running.
Yes. The abstraction layer that we've created is fascinating. Everything from Docker down to up to Kubernetes and the whole cloud thing. Sometimes I feel like that people didn't ask for abstractions; they actually asked for automation, right, instead of abstractions. Because sometimes when you add more abstraction layers, you'll start forgetting of what's happening underneath. Game developers have this debate, basically. Is it like, okay, now we have all of these engines that we're using, but we don't know how to write engines anymore. And apparently no one knows how to write engines anymore. Very few people do. How are we going to, do evolution there? And the more maybe we go to the cloud, to the Docker, we forget how an operating system works, and the innovation becomes less. But those innovations is what brought us here in the first place. So we're always in this fight as a system engineer between automation and abstraction. Which one do you want to give the user the ability to? I always end up being more automation kind of person, but I think the ideal scenario is having the balance in both, where you can see what's happening underneath because some things were automated instead of being abstracted. Right. And that beauty can give you the interoperability.
Interoperability. Yeah, I struggle with that word too, Antranig. Yeah, but I think it's interesting. Like, I think it depends on the team, right? But you still want teams focused on the operations and infrastructure in that abstraction. Because developers can create a Docker file, right? Some will create it pretty crappily. Some will do a really good job of it, right? But I think as you scale and grow, and also to support the infrastructure, you want to have people that are focused on that abstraction layer, making sure that it's interoperable, that it's secure, and allowing your developers to focus on, like, maybe developers shouldn't really have to define the Docker file to that level of granularity, right? Let them focus more on the software and the code aspect of it and less on that. And I think that's going to vary. It's going to vary between teams, right? Where's your expertise lie?
Is that abstraction or is that automation? Are we abstracting the security from them, or are we automating the security? Where
I think it's both.
They're going to make a great file, but they don't consider security because it's not really a thing. One of the biggest things that I see, like you're spot on, Antranig, is the circling back and remembering the roots and remembering why we do things and not losing some of those skills and visibility pieces. But we also are losing, like, with this automation and abstraction, both sides of this, we really have to consider, like, how are we doing good security in containers? How are we getting the visibility? How are we doing good logging? Like, all the things, like, we've got the securing, and that's one of the things I see around, like, Linux and even BSD is, like, we can secure this, we can harden this device, and we've got this very good platform and stack, and it's optimized.
Right. Or we can run everything as root.
But we also don't have any standardized visibility. Like, you look at, between EDR and XDR and all of the threat platforms and cloud security and heuristics and log monitoring and ingestion, all those things are pretty well exclusive to Windows outside of stuff like OS Query and some of the others. But for the most part, when you're talking about how you're getting that visibility, this is not the first thought that people are doing, which is why I think your company doing the deception and getting some of that visibility for BSD, Linux, Unix-like operating systems, and the Windows side. Like, those are key points that we have to keep in mind as we're trying to secure this stuff. It's one thing to secure, it's another to secure, verify, and have that visibility as well.
So putting our company's product deception thing aside, I think the visibility in Linux is getting very good because for years, this problem has been solved in Solaris. and they had this amazing technology called dtrace, which is dynamic tracing, which is you tell the operating system what you want to see and how you want to see it. And it will tell you. That's it. It will tell you. But Linux lacked this. We had simple things like strace and maybe ltrace for tracing libraries. But to know specifically which process is doing what and doing that in a very lightweight manner that it doesn't affect your production, we didn't have that for a long time. But then came Evpf, which is extended Berkeley packet filter, which has nothing to do with Berkeley or packet or filter. It just
It's terribly named, but you're right. It's dtrace for Linux. Yep.
Yes, it's basically dtrace for Linux, and I think with the Evpf becoming gaining more support, and I mean FreeBSD always had dtrace, but with Evpf happening on Linux, I think this is a very good opportunity to see what's happening in your system in a proper way. Now, the sad side of it is, which is also a problem in dtrace as well, is you need to have a very good amount of knowledge to know what you're doing.
To
it's not something that you can say, run.
Yeah. Right? I'd like it to be more user-friendly in that you don't need to have studied eBPF or dtrace and system calls down to that level, that you could run a container and it would be an easier message to go, yeah, dummy, you need this level of privilege to run that. And like, don't make the whole container root. Like, you just need to allow this one system call, with AppArmor or whatever it is. What do they call that? Capabilities, Linux capabilities. Like, just allow this, and that'll allow it to work, right? Instead, you get these really weird errors that you don't know what it means, and you Google search them, and someone makes a Stack Overflow post, and you're like, oh, I just put -- privilege in my container, and it works, and that's my solution.
Does that also have the ability to like filter and provide good visibility around like IOCs and build rule cases around known bad and heuristics that, things that should not be happening? Like, that's really the hard part for me coming from the Windows side, is I know what's evil on Windows and I can pretty well go find it. It's a little bit more difficult for me to do that on a Unix-based system just because I'm not as familiar.
So what I ended up doing is someone asked me, like, can you put this machine in a very hardened mode? And for me, hardening has three aspects. One of them is prevention, your typical stuff from firewalls and isolation, and the next one is mitigation. Basically, everything that you can mitigate, from address of memory down to what kind of privileges does a user have, preferably. And then the last part is, of course, visibility. And on the visibility part, what we ended up doing is we know which processes need what. For example, a typical process would never need to see etc password, right? A PAM would need that, right? Or your NIS if you're that old, which they happen to be. But your typical process would not. So what we can do is we can tell eBPF, tell me any process that's trying to open or stat or read the etc password file. We have just a small process that's just checking for that. And then we have a small process checking for what are processes opening. For example, we know PostgreSQL will need to check its own directory and a couple of other system files and nothing else. So we do, whenever this process looks for anything else, let me know. And it takes a long time. I think it took us like maybe 2 weeks just to figure out what each process should be doing. And then we ended up writing the reverse rules. Okay, we know what they're supposed to do. Now we write rules that tells us in a beautiful JSON format that this is what they are not supposed to do, and log it if you see something happening. So it takes time and knowledge. But this also comes back to the point of abstraction automation. Maybe creating a simple, in FreeBSD we do have that. Dtrace is hard, but we have a tool called the dwatch, where you can say dwatch open. So any process that opens anything from a socket, a file descriptor, anything, you will be able to see it. So it's both automation and abstraction in how dwatch is created. But if we, over time, I think the community will build dwatch style tools for eBPF. And at that point, you can just put the output into your monitoring system, and now you have notifications when processes are doing things that they are not supposed to do.
Antranig, explain at a very high level, give the elevator pitch for Elluria security.
Right. So Elluria is a cyber deception company. We have a cyber deception product called Profiler X, which is a honeypot on a steroid that helps you to detect, deceive, and deter the attackers. That's the very high level. On the lowest level, for the the tech folks, it's basically high interaction honeypots built in a way that not even the honeypot itself knows that it's a honeypot. It's actually pure Unix systems running multiple advanced technologies. So the attacker would never know that this is not a production system. And the security pitch of it is that it's built on two concepts. We give you vulnerable servers and we give you valuable servers, because that's what attackers look for when they are trying to penetrate your network.
Can you also do IoT and various different types of devices?
Good question. Right now our system is actually basically pure Unix systems that are running in a chroot style isolation. Yeah. If those IoT systems are running on let's say Linux or the BSDs, we can take the binaries and run it on our systems, or we can also imitate them that they can look the same way. Okay. So from the attacker point of view, it wouldn't make much of a difference.
So your honeypots aren't able to emulate Windows machines right now. They're Linux, Unix, BSD type machines. But that's fine. I mean, that's what most servers at enterprise companies are anyway, right?
Yep. One of the beauties of this is that with having a virtual networking on our roots, our isolated systems, and using visibility tools like dtrace Evpf, we are able to see everything coming back and forth. So even if the scanner does a simple a ping and an nmap or whatever that they try to do, we can see everything in detail. Also on the process level, because XRDP would not tell you what the RDP password is in its logs, but we can see it in the process object. So it goes as deep as the code is written. So we can
so you can emulate services
with the whole stack.
You can emulate Windows-based services, in other words.
Yes, that's what we do. We do emulate SMB. We don't emulate SMB. We run SMB itself. We just run Samba.
Yeah.
Yeah, his tech really sucks from an attacker standpoint. Like, it is super there's usually a flag, ways to tell, things that we do to avoid sandboxes, to avoid honey tokens, nuances with inside of either user attributes or very small nuances around a service or how it's interacting with us. The way these guys are running the stuff is, from an attacker standpoint, is truly terrifying. I just can't imagine spending weeks on something that I've just been spending a high amount of time, high interaction, and continually moving forward thinking you've got something going, and it just doesn't go anywhere. It's great.
I'd love to take a lot longer time to discuss the differences between your company and TrapX and Elusive and all those guys.
We've had a lot of those conversations, Josh. You just weren't in on them yet. But Antranig is probably more than happy to chat with you about it.
I'd love to, honestly. It'd be a lot of fun.
Bit and kind of get into some of the nerdy tech side of this. So this was a for Chris's debut. He really wants to talk about it.
Chris is Antranig's partner, by the way. We keep mentioning Chris and not saying who he is.
Yeah, everybody knows Chris. Chris from Armenia.
Right, Chris, Chris from Armenia. Antranig, I just have 5 questions left for you. Are you ready to play 5 questions with Security Weekly?
Yes, sir.
3 words to describe yourself.
Curious, terrified, always in a war zone. I think that's 6 words.
Yes. If you were a serial killer, what would be your weapon of choice?
A computer.
If you wrote a book about yourself, what would the title be?
I have no idea, but I'm guessing lucky. Like just lucky.
What is your favorite hacker movie?
This will sound cheesy, but Hackers, 1995.
Yes, Hackers. It's a good answer.
Yeah.
Choose 2 celebrities to be your parents.
Alive, dead, fictional, or otherwise.
Well, I think I Paul is one.
Aww.
And he says then the lights go off, of course. He's angered the gods with that selection.
Yeah, Paul is one. Always been as kind of a father figure. No.
It's because he's old.
I can't tell. or maybe because I'm young, but sure, let's just keep it because he's old.
Good answer.
But yeah, Paul is one. I can't think of anyone else at the moment, but I think Tyler will be my brother.
There you go.
Wow. Immaculate conception.
Wow. Antranig, thank you. And thank you very much for appearing on Paul Security Weekly.
Merci.
Thank you very much, gentlemen. I will, hopefully I will join you again one day. And thank you for hosting.
I hope so. You better.
Soon.
That's
it's 5 a.m. here.
Security news coming up next. Stay tuned.